Okay, so in this video we're going to be talking about natural logarithms. In a previous video I have done this graph before, but now I can obviously go into a little bit more detail. So in this graph I've labelled them, so this blue line is representing the graph e to the power of x. Okay, so if you haven't done exponentials yet, you need to go over that at some point. The videos that these are people are for, they've done exponentials, so they know what they look like. Okay, so the opposite or the inverse of the exponential is called ln of x. Okay, so ln of x is just logarithm, but the base is the exponential. Okay, now the reason why they're the inverse is because if you look on the graph, if you reflect it in the line y equals x, they're a mirror of each other. Okay, so I've written all of this here, so just in case you wanted to write stuff down. So ln of x is the reflection of the graph e of x in the line y equals x. Okay, they are the inverse of each other, and this is what happens because they are the inverse. Now we're going to be using this rule quite a lot to help us with solving the equations that are below. So if you had the exponential of ln of x, that's equal to the ln of x with e to the power of x. Okay, now if we simplify that, so rewrite the ln of x, it would look like this, so log with the base of e. Okay, now using the laws of logs, the power can then come to the front, so it would look like this. And just remembering that if you've got a log with the base and the number here being the same, that's equal to 1. Okay, it does work in the reverse as well. So if you had ln of x, if you took the exponential of that, you would then be able to get x as well. So we're going to be using those rules to help us with these questions here. So I'm just going to move it up a tiny bit, but you'll still be able to see the rule that is here. So for the first one, solve the equation given your answer in exact form. So we're not actually going to be using a calculator at all because it does say exact form, so we don't need to. So for e.g. 1a, we've got e to the x equals 5. So to do that, we're going to take logs of both sides, but we're going to do the natural log. So we just write ln. So ln of e to the x equals ln of 5. Okay, so similar to a previous video, you do the same to both sides. Now, the log of an exponential will just give you x. Okay, this doesn't simplify, so we just leave it as ln of 5. Okay, and that is the final answer. So we don't need to put it into a calculator. The reason why is because it says exact form. Okay, so similarly for the next one, if we have ln of x equals 3, so to get rid of the ln, we do the exponential of it. And again, exponential of the other side. Okay, the exponential and the ln cancel each other out, so you'll just be left with x, and this side will still be e to the power of 3. Okay, so these are the most basic ones that you can get. Okay, and using the similar skills, we'll then be able to do the harder ones that are below. So for e.g. 2a, so we've got e to the 2x plus 3 equals 7. So we're going to do it very similar to the one above. Okay, it's just going to be a little bit more fiddly afterwards. So step 1, take ln's of both sides. Okay. So ln of e would be 1, so we're just left with the power. So 2x plus 3 equals ln 7. Subtract 3 from both sides. So we've got 2x equals ln 7 subtract 3. Now the 3, you can't like subtract 3 from the 7 or anything like that, okay, because think of it as like a function, you can't touch it. Okay, and then we divide by 2. So x equals ln 7 minus 3 all divided by 2, and it says again we need to leave it as exact form, so we can just leave it as that. Okay, so for the next one, so before we can take exponentials, you want to have the ln's on its own. This one was okay because the power, but if we had like a 4 in front of the exponential, we would have to divide by 4 first before we can take the ln's. Okay, so I'm going to deal with the -1 and the 2 first, and then we can take exponentials of both sides. So subtract 1 from both sides. So we'll be left with 2 ln x is equal to 4. Then we can divide by the 2 at the front. So divide by 2 on both sides. So we're left with ln x equals 2. Okay, then it's very similar to the one that we've done here. So take exponentials of both sides. Okay, exponential of ln is just x, and then you'd have e to the 2 still there. Okay, now the next one is just another one to look out for. This one is a quadratic one. So the first thing I want to do is I'd need it to be equal to 0 to be able to solve it. So I'm going to subtract 14 from both sides. So e to the 2x plus 5e to the x minus 14 equals 0. Now I'm going to leave it as e to the x, okay? You could change it, so you could write that y is equal to e to the x and replace them or substitute in so that they're a little bit easier to factorise, but to be honest it's not that much easier. So we're definitely going to have e to the x at the front of both of them, because e to the x times e to the x will give you e to the 2x. So just remember, you add powers when they're multiplied together. So we need two numbers that multiply to make minus 14, and the same two numbers to add to make 5. So it's going to be 7 and minus 2. Okay, so you get two answers. You'll get e to the x equals minus 7 and e to the x equals 2. Now this one is not a solution, okay, because when we do the next part, which will be take lns of both sides, we'll get ln of minus 7. I'm just going to scroll down a little bit. So the reason why I did this graph is just so that you can see that this ln will never go past the y-axis, okay? So it means that x will never be 0, okay? X is never smaller than 0, okay? So that means that when we do this part, we can't actually take lns of that because it would become ln of minus 7, which is impossible, okay? So that one we don't need to carry on with, okay? But this one we can, so we take lns of both sides, okay? And again, the ln and the exponential cancel out, so you will be left with just x equals ln 2. So we only get one solution out of that one, okay? So just be really careful that you watch out for those little issues.